So yeah, my name is Jesse. This is Michael Lincoln. There's others who are working on this as well, but couldn't make it. And this talk sort of was born out of our experience on implementing the Bayesian workflow, in which I think other people may have that kind of the kind of context, but I haven't seen it discussed as much. And that's within sort of a larger sort of pipeline. I think the traditional way people talk about it is like a machine learning pipeline kind of thing, right? Where you have several people before you, several people after you. And it is sort of our sort of lessons learned from that. Also sort of involuntary therapy session for me, this is good. And so this painting here, very famous. Hieronymus Bosch, 1500s, very famous Dutch painter. The traditional interpretation is man is created in the Garden of Eden, but as they succumb to the fleshly delights of the world, they slowly descend into hell. But all art is sort of interpreted through experience. So my experience, my interpretation is this is what it feels like to implement the Bayesian workflow when it's just you and other people who care about who care about Bayesian statistics. And it's great, and it feels awesome. Maybe this is Bob or Richard, who knows, But as we slowly move on to here, I'll go to this one, move on to here, where because the role of the workflow, right, I think in Jim Savage's original modern statistical workflow post, was to maximize your chance of your model being useful. And I think useful is a very important term where it diverges from when it's just you and a couple other people to when there's lots of people that are, when you pass the posterior on to other people who don't know what a posterior is. Like here's me, here's Michael. This is the sysadmin that won't give you root permission on the server. That's probably the upper management that asks, when's it going to be done. But there's just a whole new set of just experiences and things that arise that get in the way, or I think we sort of deserve to be named and discussed in these sort of contexts. And so the context in which we got this model is, most of the time when we think of the Bayesian workflow, and I do at least, it is, okay, I'm creating a model from scratch, or like I can think through reasonably how I want to develop more and more complicated models. But we sort of took over this complex model that already existed. So not only is this for this workflow that we were doing just for this one thing, but it's just, we don't only have to maintain it, we have to improve it over time. So if we're going to improve it, we need to understand it, right? And so that's where Michael came in. Michael did great on sort of just disentangling everything, right? So we tried to, instead of building this model through the Bayesian workflow, we try to use the Bayesian workflow for disentangling this already complex spaghetti code type model. So pretty much the overall lesson learned, and then I'll get into more details. If you paid attention to nothing else, this is the analogy that matters here. So in the Olympics last month, the United States was the favorite to win the 4x100 relay. Fastest people in the world, not even close. But the reason they failed was because of bad handoffs, right? The first handoff, they didn't do it right, and they got entirely disqualified. And so the analogy here is that handoffs matter, right? When more and more people get involved, the handoffs between people are increasingly become a larger and larger source in which your model may not become useful. Your model may be correct, it may be the best simulation-based calibrated model that ever existed. But if the people you hand it off to that are running it and doing things like that, if the handoff is not thought through, it could still fail. And so we could have started thinking about this uncertainty due to this sort of handoff things. And so traditional notions of uncertainty in Bayesian modeling, right? You think of it epistemic, aleatoric, right? The uncertainty due to the lack of knowledge of things in the world, aleatoric, randomness are models. So this is a fun little graph that kind of gives you a little insight of kind of the model. One of the models that we're working on for this is, so one of the things we're doing with this model is trying to predict building attributes all around the world, and what buildings are made out of, the materials, how big they are, the roof types and things, right? And so you get fun little things like this, where apparently in France, any new building that is built over certain square meters needs an architect's approval for being approved. And do you want to guess where that is? Right? And so these are kind of cool. It's interesting, right? This kind of like incorporating this real world experience. And that's what I think the Bayesian workflow gives you a framework to do, right? Work through and reason through, is build out more and more complicated models to try to understand these things, right? But what do we call the kind of uncertainty that arises when someone just quits? The person that was in charge of this model, this person that was developing it, and, but now you need to like take it over and go, okay, what do we do now? That's not really those two. And so the handoff analogy, that those kind of became the main sources, because if we all speak the same language, the Bayesian language, and we all know, if we all know what a prior predictive is and things, then we can work through these kinds of details, right? But things like this, you're like, oh, I don't know. And so we kind of came up with a workshopping a definition, call it collaborative uncertainty, like a new kind of uncertainty. I don't know. And so the uncertainty that kind of emerges, right, when just us fallible human beings start working together, right? And in many contexts, sort of uncertainty and collaborative uncertainty is not really the main source of model not being useful, because everyone sort of, we collaborate, very closely with each other most of the time in the scientific community, at least, your team. But as more and more people get involved in these implementations of these models, which I think in these larger organization settings, that's no longer the case, right? The marketing manager does not want to read the 75-page Bayesian workflow paper, and if they did, they don't care about what it means. But they can definitely make your model not useful, even if it's correct. And so I kind of wanted to just introduce the idea, give a name to it. I don't know if anybody else has any kind of like experience that this corroborates these kinds of things, but just some of the. By the way, all of these images are prompts from ChatGPT of in the style of Hieronymus Bosch of whatever things might be. So some examples. Like for the organizational dynamics, like the reason Michael and I got started working on this model is because the person who was in charge of it just quit and got a new job. And you're like, okay. And so, but that happens, right? But one of the roles of the national labs too in the United States is to maintain these long-term R&D projects to help give better answers to questions for the government and regulatory things and other sort of decisions and things that they have to make. And so it has to be maintained. We can't just give up on it. So there's that. Communication gaps. One of the things that I've noticed is that the paper is not the code base at all, right? There was a paper that was written, and it was a snapshot in time. Then the code got kind of worked on for a while, then worked on, and of course they just diverged. But that's okay, you can figure that out. But then one of the things that kind of popped up was that the more upper management, so senior scientist people who have given up coding, and they're just reading the paper like, that's not how it works. No, this is how it works. And they point to the line in the paper. I'm like, I don't know, that's not how it works. This is it. Well, the paper is not producing numerical estimates here. So, and also the decision-making process of things where as you go on and on, the uses of your model may drift. Like in our cases, we train a model, say in some city where we want to predict the attributes, and well, how about this other city? Okay, well, and then the variables are totally different. Or in one example is that we have our data people where they're great data people, and we have one detail about the models. Part of it is categorical, or we're trying to predict. Say, for example, the purpose of the building, commercial, residential, industrial, it might be. Our data guy is great. Jason's phenomenal. But he's like, all right, we have a great data set. We have 96 different variable types of residential. I'm like, I don't think, maybe we just have one, please. And so that sort of model decision making and how we do that, also on downstream. And for a bit of coherence, I'll throw it to Michael so he can talk about his actual experience on doing these things, and then we'll wrap up.
I don't have a microphone, but I can speak loudly. Hopefully it's still picked up by the mic at the camera. But yeah, so I mean,
grab the mic.
I can grab it.
Recorded.
I can grab this mic. Or just yours.
Yeah,
oh, Jesse's mic. Oh, right on. All right, there we go. So yeah, so from my standpoint, I came into the lab kind of midstream, or I don't know, maybe even late stream compared to others that were working on the project. The code was standard research code. It was kind of built in like isolation. There was no testing. It was just a giant monolith of Python code sprinkled in with all kinds of other little scripts and things like that. So what we really needed to do first, if we were going to actually move forward, was take all that stuff, untangle all those pieces like Jesse had indicated before, get tests around them so that when we were actually making changes, we could actually say, okay, yeah, we're getting things that are within the range that we expect, or we're not. So that's what I did. I came in, I wrote a lot of stuff in PyTest to be able to have proper unit testing, some integration tests where we couldn't really have proper unit testing around some of the disentangled code bases. We brought everything into the modern era in terms of like more modern versions of the libraries, all that kind of stuff, which gave us a really nice speed up. Then encapsulation really gave us, a substantial amount of speed up too, just by not, double dipping on certain types of steps, data munging, all that kind of thing. Once we did that, we were able to get things into containers, which then allowed for more of that collaboration, a little bit less of just kind of the miasma of like, how do we hand this thing off to other people, and then also able to get it onto some of the larger compute machines, compute resources that we have at Oak Ridge, which is really one of the things that makes all of our science possible, is that we have these really fast machines. But if things aren't encapsulated and aren't ready for that kind of end, then you're going to be in a place where you can't hand things off. So we did that, and it was me coming in as kind of an outsider to this Bayesian world. I have a science background, mostly in the geospatial stack, but very curious and have gotten a real kind of deep dive into this world over the last year of being there and getting really, really interested in it. That's why I'm here.
In here in hell.
It's somewhere, yeah, somewhere in here. And so I'm coming in trying to collaborate with these really brilliant scientists, people, PhD students, all that kind of stuff coming in. So we're trying to kind of build that collaboration framework for us to get away from that collaborative uncertainty and towards a place where we have a lot more continuity and understanding of each other, and then we can collaborate not only within our Bayesian world that we live in, but also with all the other geospatial folks that hopefully consume this data and then provide us data moving forward. So.
Yeah, one thing that really came into play was the idea, there's computational efficiency, and then there's human efficiency. And the more people are involved in the work, the more important the human efficiency matters. I cannot tell you how important the input file formats were. We're trying to understand just what is going on. And so anyway, so all this, of course, is not restricted to just Bayesian ideas, right? And the Bayesian workflow is limited in what it's supposed to do because it's good in its scope. And so in the idea of handoffs, this is something we're exploring now. There's a really good paper that came out a couple years ago that uses the idea of technology readiness levels. I don't know if anybody's familiar with that. They came out in the 70s from NASA, where they wanted to make sure that when they launch a space shuttle, it's going to work, right? And so extraordinarily rigorous. This is what the extraordinarily rigorous ways in which they confirm, make sure things work all the way up. And so some folks from NASA and some other large organizations said, okay, that's a good idea. And that's the language that, like, a lot of times our sponsors, government sponsors, speak, right? They'll ask me, what's the TRL? I'm like, 2, I don't know. But in the sense of minimizing collaborative uncertainty, right? What these folks did was, okay, what does TRL look like from a machine learning model perspective, right? And it's actually really fascinating because when you read it, pretty much all of this part, they don't use the same language, but it aligns exactly with the ideas of that the Bayesian workflow talks about, right? With very simulated data, make sure your expectations are there, and then build up the different things over time. But it also adds a little bit of the language that these people over here can understand and hopefully not misconstrue too bad. And so, anyway, I feel like there's opportunities there for us to engage in that kind of discussion about because Bayesian models are already hard to understand anyway, and now they're being implemented more in these more larger pipelines. I feel like as a community we should try to, embrace that and see what we can do to make that, grow as much as we can. So maybe this handoff overlap. Maybe there's areas in which there's a good translation there. And of course, the obligatory call to action. This is Thomas Bayes giving a talk, giving a call to action talk at Oxford in the style of Hieronymus Bosch. That's what ChatGPT produced. But the call to action is that as more and more of the applications of these Bayesian models get into these larger organizations, these sort of pipelines, more and more people get involved, and more handoffs are there, and therefore to sort of give a language in which we can maybe think about it, this idea of this. The more collaborations there are, the more handoffs there are, the more the collaborative uncertainty becomes the source of your model not being useful, and we should think about that. And that's it. It's a pretty picture. By the way, the fastest computer in the world is right here. So.
Do any of your models have to work in an unsupervised way? Not in the sense of unsupervised learning, but like...
Yeah, so the predictions are generally used in unsupervised ways. What happens now is that the model gets used, we make these predictions about these buildings, and these buildings, the attributes get used into other models, right? And a lot of times we don't know what areas in which they are going to be applying it to. They say, oh yeah, these buildings, and we have to give it the data, and so in many ways, understanding how the predictions are working and doing, it's hard to keep up with. Yeah.
I'm curious about what are some large models that you do Bayesian analysis on. Do you use Stan for these models? What's the scale in terms of compute time cores that you deploy?
Yeah, so because of the we came into it, right, is actually implemented in PyMC3. And then Michael and Pranav did a great job of getting that to PyMC5. I'm more of a Stan person. The goal, right, aspirational model would be every building in the world, right? But, take a back step. And so generally what we try to run them on around city levels, 100,000 or so, 200,000 buildings. There's lots of missing data. Essentially the model that we inherited is sort of a nested categorical model with sort of a car signal there. And so yeah, depending on how many imputation steps and things like that, it takes probably.
I think about 2.5 hours. I think or at least with PyMC5. With PyMC3, we were hitting some really slow times.
And it depends on the data.
What is PyMC5?
It's just PyMC, or it's
PyMC version 5.
Version 5. So
Is there anyone from PyMC Labs here?
Yeah, there's some people here.
Yeah.
Just on PyMC now.
PyMC.
PyMC, all right. So we've
That's the collaborative uncertainty.
Yeah, there we go. So we've learned something too. But yeah, we were just moving versions because things were kind of in this legacy thing, and in the Python world, all that, everything changed from some of the base libraries that were being used there. So we ended up shifting our gears towards a newer version, which was faster, cleaner, easier for us to write. And then being here, because Jesse is very Stan focused, this is really kind of my first foray into learning about it, and I've enjoyed every bit of it from the tutorial, even at Big Bay. But I think that's going to be our next step too, is kind of try to or have different containers. We have other types of ways to do our modeling too, inside of that more kind of standard neural network, optimal transport modeling way of doing. But our Bayesian approach is really what our funders have been looking towards. And if we can gain better speeds, cleanliness, and then also portability from LLVM languages around, which really seems like it's a huge piece to stand, then I think we're going to move in that direction too. So I'm learning here, and yeah, it's great to chat with everybody and become part of the community.
Yes?
I'm in very similar situation to you, so I feel your pain. I've inherited a model that was developed by someone over 5 years, then they left the company.
Oh yeah.
Now there's me and a guy in Denver. We've got it's mobile phone data in the US.
Oh, cool.
Take it international.
Yeah.
It was never designed for how it was going to ever be maintained.
Preach. Yes.
Yeah.
Yeah. Well, and I would like to talk to you offline about the mobile phone stuff. Yeah, it's interesting.
That's